Hello, welcome to Anybody Can Learn. Today we will learn ridge regression. But before that, let's recall what is a regression. A regression is a machine learning technique used to predict the continuous numerical value. The output in the regression is always a number. Regression tries to learn a relationship between the input feature and the output targets. For example, the input is house size, then it will predict the price of the house, that is for example 25 lakhs rupees. If the input is temperature, then it will predict the 32 degrees Celsius as a temperature. Another example is, if the input is study hours, then it will predict the mark of 10, that is 87 marks. If the input is year of experience, then it will produce salary as output, for example 8.50 lakhs rupees. Continuous number means a pure number like a 32 degrees Celsius or a 87 marks. Recall what is a linear regression. A linear regression assumes the relationship between the input and the output is approximately a straight line. The formula for a single feature is y is equal to wx plus b, where y is the predicted value and x is the input feature and w is the weight or the slope, and b represent the bias or the intercept. So this is a bias or intercept y, and weight is a slope or the weight. What does the weight and bias means? Weight tells us how much output changes by if the input is changed. Weight tells us how much output changes if the input is changes. For example, if the weight is 5, then every extra hour of study will increase marks by about 5. And bias tells us the starting value when the input is 0. If y is equal to 5x plus 10 and x is 0, then 10 is our bias, that is 10 is our b. In real world, we have many features to predict the one target. For example, to predict the salary, we have the many features like experience, education, skills and projects. Then the formula for the multiple features is y hat is equal to w1 x1 plus w2 x2 plus w3 x3 plus w4 x4 plus b. This equation can also be written as y hat is equal to w transpose x plus b, where y hat is the predicted output from the model, w represents the weight vector, for example 2, 3, 5, 1, and x represents the feature vector, for example 10, 2, 7, 5. W transpose x means multiply corresponding numbers and add everything together, that is 2 into 10 plus 3 into 2 plus 5 into 7 plus 1 into 5 is equal to 20 plus 6 plus 35 plus 5 is equal to 66. So our W transpose x in this example is 66. The learning process is, initially we choose the weight randomly, so our error or prediction are also poor. So we compare the predicted value with our actual values to find the error. An error is calculated by the formula y minus y hat, where y is the actual value and y hat is the predicted value. Mean square error means for thousands of samples, we calculate the square error for every sample and then average it. That is, MAC is equal to 1 upon n multiplied by summation of square value of y minus y hat, where n is the total number of samples. Why the square the error? Because if the errors are 3 and minus 3, then adding them gives the 0. That is, these two errors get cancel each other, which look perfect but it is a wrong. So squaring the error make them 3 square is 9 and minus 3 square is 9. So they do not cancel each other. The goal of the linear regression is to find the weights that minimize the mean square error, that is MSE. What is the overfitting model? Sometimes training accuracy becomes 99%, but the model may have just memorized the training data. Imagine a student A understand the concept while the student B memorizes every question. In an exam, student A performs better. Similarly, if the model memorizes the training data, it performs poorly on a unseen data. The main symptoms of the overfitting is a very low training error but a very high testing error. One important reason for this happening is because of the very large weights like 1000, minus 900, 700. Large weights makes the prediction changes drastically, even for a tiny changes in the inputs. Large weights are highly sensitive to noise. What is regularization? The regularization means adding a penalty to discourage overlay complex model. It tells the model to fit the data well, but do not use unnecessary large weights. Large weights makes the model highly sensitive to noise instead of the true patterns. A small change in the input create a huge change in the output. So small weights make the model more stable and less likely to overfit. So small weight means stable model. Now understand what is a ridge regression. Ridge regression simply is the ordinary linear regression plus L2 regularization. So J of W is equal to MAC plus lambda multiplied by norm of W square or norm square W. The first part, that is mean square error, which measures the prediction error that we want to be the small, and the second part, that is regularization penalty term, which actively discourage the large weights. The L2 penalty, that is norm square W, is the sum square of weights, written it as W1 square plus W2 square up to WD square, where D is the number of the samples. It is also called as a L2 norm square, which measures the overall magnitude of the weight vector. For example, if the weight vector is 2 minus 3 1, then the penalty is 2 square plus minus 3 square plus 1 square. that is 2 square is 4 plus minus 3 square is 9 plus 1 square is 1. So 4 plus 9 plus 1 is 14. So our penalty for W is 14. But smaller the total value means weights are collectively smaller. Why we square the weights? Squaring ensures the positive and negative weights both contribute positively. Otherwise they will cancel each other. A very large weight receives a much large penalty and the smaller weight than the smaller weight. For example, a weight of 2 contributes 4, but a weight of 10 contributes to 100. Ridge regression strongly discourages extremely large weights. Now understand what do you mean by lambda. A lambda is a regularization parameter. It controls how much importance is given to the penalty in the cost function. If the lambda is exactly 0, then there is a no penalty. The model becomes ordinary linear regression. If lambda is small, then there is a mild penalty and the model focuses mainly on fitting the data. And if the lambda is large, then there is a strong penalty and weights are pushed closer to 0. A very large lambda can reduce the overfitting but may make the model too simple. Now consider a practical example. Suppose we have two models, model A and model B. Both the models have same mean square error, that is MAC is same for both the model, and the weights for the model A is 5, 4 and 6. Now let us calculate the penalty, that is a norm square for W, that is 5 square is 25 plus 4 square is 16 plus 6 square is 36. So 25 plus 16 plus 36 is equal to 77. Now calculate the norm square for the model W, and the weights for W are 1, 2 and 1. So 1 square is 1, 2 square is 4 and 1 square is 1. So 1 plus 4 plus 1 is 6. Now the question is, which model the ridge regression will choose? As the MAC is same for both the models, the ridge regression will choose a model which has two lowest cost. Now the cost will depend only on the penalty, that is the model which has a lower penalty, ridge regression will choose that model. In this example, the 6 is the lower than 77, that is penalty for model B is less than model A. Therefore, ridge regression will choose a model B. Remember that ridge regression will choose a model which has a total cost is lower. Now let's see the advantage and disadvantage of ridge regression. Advantage of ridge regression is it effectively reduces the overfitting and it also stabilizes the model. Ridge regression work well when the features are highly correlated. It is also known as multi-collinearity. As well as ridge regression uses all features while shrinking their coefficient, and it often improves the performance on unseen test data. The disadvantage of ridge regression is it does not make the coefficient exactly 0. So we cannot use it to perform the feature selection. If the lambda is too large, then the model may become too simple and underfit the data. And the disadvantage of ridge regression is also the exact value of the lambda usually needs to be chosen carefully. Now let's compare the linear regression and ridge regression. Linear regression minimizes only the mean square error, but the ridge regression minimizes both the mean square error plus the L2 penalty. Linear regression can produce very large weights. Ridge regression naturally shrinks the weights toward 0. Linear regression is more prone to overfit the training data. Ridge regression actively helps to reduce the overfitting. Linear regression uses absolutely no regularization, whereas ridge regression relies entirely on L2 regularization. So these are the some technical terms. Feature means the input variable and target is the output value to predict. Weights tell how strongly a feature influences the prediction, while the bias is the constant added and norm is the major vector size. The prediction is the output produced and error is the actual value minus the predicted value. That means it is a difference from the actual value. Regularization added a penalty to complex model and L2 is based on the square weights. So overfitting learns the training data too closely, while the underfitting is too simple to learn patterns, and the cost function is a mathematical expression the algorithm tries to minimize. So these are the some important formulas. Y hat is equal to W transpose X plus B, and error is Y minus Y hat, that is actual prediction or actual value minus predicted value, and MAC is a 1 upon n multiplied by summation of square of Y minus Y hat, and L2 penalty is norm of W square or norm square W, that is summation of W square, and ridge regression is MAC plus lambda multiplied by norm square W. Now let's solve the question. So question 1 is, assume that for a certain linear regression problem involving 4 features, the following weight vectors produce an equal amount of mean square error. So W1 is 2 1 2 2, W2 is 1 2 1 2, W3 is 3 2 2 1, and W4 is 1 1 1 2. The question is, which of the weight vector is likely to be chosen by the ridge regression? And the option these are the options given to us. A is W1, B is W2, C W3, D W4. We know the ridge regression formula is MAC plus lambda times norm square W. Now understand the question carefully. The question mentioned that the weight vector produces an equal amount of mean square error, that is all 4 feature vectors produces the same mean square error. So it means MAC of W1 is exactly equal to MAC of W2 equal to MAC of W3 and is also equal to MAC of W4. Since the MAC, that is mean square error, is same for every operation or for every option, the ridge regression does not need to compare the prediction errors. Instead, it compares only the regularization penalty, that is, it will compare only the lambda multiplied by norm square W. So lambda is regularization pattern parameter, and it decides how much importance is given to the penalty term. Larger the lambda means stronger the penalty, and small lambda means weak penalty. Since MAC is the same for every options, the quantity only changes is a norm square W. That is, norm square W is a summation of Wi square. So let's calculate the square length for each vector. W1 is given as row vector 2 1 2 2. So calculate its norm square W. 2 square plus 1 square plus 2 square plus 2 square. 2 square is 4, 1 square is 1, 2 square is 4, 2 square is 4. So 4 plus 1 plus 4 plus 4 is 13. So for option A, W1 norm square W1 is 30. Similarly calculate the norm square for weight vector 2, that is 1 2 1 2. So norm square is 1 square is 1, 2 square plus 1 square plus 2 square. So 1 plus 4 plus 1 plus 4 is 10. So norm square of W is 10. Now calculate the norm square for W3. L2 norm square for W3 is 3 square plus 2 square plus 2 square plus 1 square, that is equal to 9 plus 4 plus 4 plus 1 is equal to 18. So norm square W3 is 18. Now calculate it for the weight vector 4. So norm square W4 is 1 square plus 1 square plus 1 square plus 2 square. 1 plus 1 plus 1 plus 4, so it is a 4. Now let us summarize all the square length. W1 square length is 13, that is L2 norm square is 13. W2 norm square is 10. Norm square W3 is 18 and norm square W4 is 7. Observe here that the fourth weight vector has a length, has a very small norm square, that is a 7. Now the question is, which weight vector will the ridge regression chooses? We know that the MAC is same for all the weight vector as it is given in our example. Lambda is also the same. So the smallest total cost come from the smallest square length, that is smallest square norm of W. Just now we see that the smallest value is 7 for which belong to the vector W4. Therefore, our final answer is option D, W4, which is a vector with the entries 1 1 1 and 2. Thank you.